Hello, students. Time for another video. I am going to be looking at assignment number 27 with you guys. Assignment number 27. And we are solving quadratic equations. Now, these are also referred to as second degree equations because the highest power is 2. Now, the quadratic equations may be in the form of ax squared plus bx plus c equals to 0. And so, when you have a quadratic equation, guys, a cannot equal to 0 because if a is equal to 0, you no longer have a quadratic equation. So the ax squared term is called the quadratic term. Let me go ahead and also throw this term in here. A is called the leading coefficient. And the leading coefficient is the number in front of the term with the highest power. So in this case, the a is in front of the x squared. And since x squared is the highest power, so a becomes the leading coefficient. Bx is referred to as the linear term because, of course, it's with x. X is linear. And then C represents the constant term. Okay, you can have just the x squared term and you have a quadratic. If you're missing the bx term, you're missing the c term, you still have a quadratic. Now, to solve these quadratic, guys, there are various methods to solve them. So here's a compilation of some of these methods, okay? And I'm just going to give you a synopsis and then we'll go through them thoroughly. We got factoring. We already talked about factoring. Factoring is very efficient, but it doesn't solve all the quadratics. It solves some of them. We have the square root property. Then we have the completing the square. Now, completing the square will solve all quadratics, except you might encounter some fractions in there. Most students don't like working with fractions. So, not very efficient for some of the quadratics, okay? And of course, everybody's favorite, the quadratic formula. Now, last but not least, I'm going to mention graphing as well. Graphing is another way to solve quadratic equations. And what are you looking for? You're looking for the intercepts. When you find the intercepts, in this case, the x-intercepts, these represent the zeros or the roots of the quadratic. So wherever the graph intersects the x-axis, that represents a 0 or a root of the quadratic. Now, let me go ahead and mention the factoring method very quickly because we talked about this back in chapter 5. When it comes to the factoring method to solve quadratics, number 1, you have to set the quadratic equal to 0. In other words, isolate the quadratic. Number 2, you want to factor the quadratic. And so once you're done factoring the quadratic, you want to use the zero product property and set each factor equal to 0 and solve. Let me squeeze the 0 over here. I don't like how it's hanging right there. Set each factor equal to 0 and solve. Now, the reason we can do this is because of the zero product property. which says if A times B is equal to 0, then this means either A will equal to 0 or B must equal to 0, because when you multiply by 0, you will end up with 0. Now, for these type of problems, guys, they're very easy. This is a very easy method to solve quadratic equations. The only problem is it's not going to allow you to solve every single quadratic. So that is why we look at other methods to solve the quadratic equations. So let me do a couple of examples using the factoring method. It works, but like I said, it only works for certain questions, all right? And the focus of this lesson right here is really not on the the factoring technique. It's more on the other methods, okay? So here's one problem right here. And this one is from assignment number 27. It's problem number 6, which can be solved by factoring. It's x squared plus 12x is equal to negative 20. So, of course, the first step would be to go ahead and take that negative 20 from here on the right side, move it over to the left side. So you can isolate the quadratic, get the quadratic to be equal to 0. So when you move the 20 over, it becomes negative 20 over, it becomes a positive 20. Now you want to go ahead and factor this into two binomials. What two numbers multiply to give you 20 and add to give you 12? Those two numbers would be positive 10, positive 2. Now that you have your factors, you set each one equal to 0 and solve, or you could just ask that basic question. What number plus 10 makes this parenthesis 0? Remember, we're using the zero product property. So that would be a negative 10. And if negative 10 plus 10 is 0, 0 times anything gives you 0. So that's one of the solutions. And then the other one, same thing. What number plus 2 makes the second parenthesis 0? Negative 2. So just like that, guys, you have your two solutions right there, okay? So x equals to negative 10, x equals to negative 2. Now when you type it in, remember you type in negative 10, comma, negative 2. So very easy problem. Remember, guys, not all problems are factorable, okay? Only some quadratics are factorable. So be on the lookout for those that are factorable. If they are, then yes, go ahead and use the factoring technique to solve them. Here's another one, guys, that's super easy. It's number 10. It is factorable as well. And so for this one, I've got z squared plus 5z minus 14 is equal to 0. It's already set equal to 0. So I'm just going to go ahead and factor this. What two numbers multiply to give me a negative 14, whose sum is positive 5? In other words, I want to find the product of two values. That gives me negative 14, and then their sum would be 5. So that would give me a z plus 7 and a z minus 2. 7 times negative 2 is 14. 7 minus 2 obviously is 5. So now I can take each factor, set it equal to 0, and solve. And that's the same thing as just asking the question, what number plus 7 makes this 0? So that will be a negative 7. What number minus 2 makes this one equal to 0? That will be a positive 2. So the solution set for this one will be negative 7, comma 2. And no, you do not have to write the solution set in sequential order. All right. Now, this is what this particular section is about, guys. One of the techniques it's about is the square root property, okay? Now, in order to use the square root property, guys, okay, you have to have the equations and a certain format. Either you have it in the form of x equals to, as in your x squared term is already isolated, or you have x minus some number squared equals to z. So something like that. So in other words, you have to have your x squared term in there where you can isolate it and set it equal to a constant. So if you have these type of problems, this is the perfect time to use quote unquote the square root property. Now, obviously they call it the square root property for a reason. At some point, you're gonna have to take the square root. Now, here are the steps for this, guys. First, you want to isolate the square term, that exponential term. And that square term is x squared, okay? Next, you want to take the square root of both sides. See, there's that square root property, both sides. Take the square root of both sides. Now, this is where you need to be super careful. When you take the square root of both sides, guys, you will get a compound solution. Two solutions, okay? You're going to get a positive solution as well as a negative solution. So it's very critical that when you take the square root of both sides, you get two solutions, positive or negative. And then the third step is to go ahead and solve the equation out. Solve the equation. Or should I say equations, because there's really two of them. All right, guys. So let me go ahead and go over some of the questions from the assignment. Number one, I've got x squared is equal to 63. Now the x squared term is already isolated, so I'm just going to go ahead and take the square root of both sides. When I take the square root of x squared, the power cancels out the root, so I'm left with x. And then I got to take the square root of 63. No decimals, everybody. You got to simplify your radical. Now, the square root of 63 can be simplified. 63 has a perfect square that goes into it evenly. That would be 9. And 9 goes into 63 7 times. So we rewrite 63 as 9 times 7. We take the square root of the 9, that gives us 3. And then the 7 remains under the root. So guys, there you go. Plus or minus 3 radical 7. Now, on Math Excel, you do have the tools palette there where you do have the plus or minus key on the calculator, on the tools palette. So you do not have to break the answer up. You do not have to separate it, guys. You could just type in plus or minus, use the plus or minus from the tools palette, and then input your solution for the problem, okay? So do not break it up, just use the plus or minus. All right. Number 2, everybody. Now for number 2, I've got x plus 8 squared is equal to 9. Obviously, the square term is already isolated, so I'm going to take the square root of both sides. When I take the square root of both sides, I'm going to get plus or minus 3. Now, the next step is to solve for x. How do we solve for x? Take the positive 8, move it over to the other side. This would give you a negative 8 plus or minus 3. This is representing two answers, guys. One of them would be negative 8 plus 3, which gives you negative 5. And then the other one is x equals to negative 8 minus 3, which gives you a negative 11. So you have two solutions. Now, alternatively, you could have just done this. Break this up into x plus 8 equals to 3, or x plus 8 is equal to negative 3, and then solve it from there. You still get the same answers, guys. X equals to negative 8, there's 1, and then subtract the 8 from both sides here. So you get x equals to negative 11. That's the second one. So see, you get the exact same answers. It really doesn't matter. All right. Now this next one requires a little bit more work. Number 3, I've got x squared plus 121 is equal to 0. I'm going to subtract the 121 from both sides so I can isolate the x squared term, get the x squared term by itself. Now, once I have it by itself, once I have it isolated, I'm going to take the square root of both sides so I get plus or minus. Ooh, there's a negative under the root, guys. Because there's a negative under the root, you know what that means. We just finished talking about these in chapter 7. So we're going to have an imaginary number. So this is going to come out to be plus or minus 11i. Be careful with that. When you encounter those negatives under the roots or the radical, you got to make sure, guys, you change it to an imaginary value. All right, next one. This is problem number 4. You want to subtract 60 from both sides. So you get 3x squared is equal to a negative 60. Remember, we're trying to isolate the x squared term, so you keep going until you get the x squared term by itself. So the next step is to go ahead and divide both sides by 3. And when you do so, you get x squared is equal to negative 20. Now the x squared term is by itself. It has been isolated. You can go about taking the square root of both sides. Now remember, when you take the square root of both sides, you get a compound solution, a positive or a negative answer. Guys, there's two things happening with this one. First, there's a negative under the root. That's going to become an imaginary number. Next, 20 can be simplified. It has a perfect square that goes into it evenly. So we can rewrite 20 as 4 times 5 because 4 is a perfect square. So now, guys, we take the square root of the 4. That's 2. The negative becomes the I. This negative right here, that becomes I, okay? That becomes an I. And I'm going to erase it, okay, because I'm not supposed to have that there, okay? And then the radical 5 remains under the root. And there you go. You leave your answer just like this, guys. There's nothing else you can do to it. So you are done with this problem. Okay, next, number 5, I've got x plus 2 squared is equal to 13. Now for problem 5, the square term, which is the parentheses squared, is already isolated. I'm just going to take the square root of both sides. So I get x plus 2 is equal to plus or minus. We cannot simplify the radical 13. We're not allowed to have decimals, so we leave it as the square root of 13, guys. The next step is to go ahead and subtract the 2 from both sides to get x equals to negative 2 plus or minus radical 13. And that's it. And yes, you can plug in this answer into the box, guys, Math Excel, okay? Just like it is. Use the plus or minus on the tools palette, okay? All right, guys, so now I'm going to move on and talk about another method, okay? And this one is going to be method number 3. And method number 3, some of you may not like it, but I'm going to suggest when it is best to use this method. And this method right here is called completing the square. Complete the square. Completing the square to solve quadratics. We're solving quadratics by completing the square. Now, these methods right here, because you guys want to avoid the fraction, it works best if A is equal to 1 and B is even. So you can avoid the fractions, okay? So if you are the type of person that doesn't like to use fractions, then you only want to use completing the square when A is equal to 1, as in the number in front of x squared is 1. B is even, as in the number in front of x is even. Okay, so if you have an equation in the form of ax squared plus bx plus c equals to 0, if this is equal to 1 and this one right here is even, this is the ideal candidate for completing the square, guys, okay? So here's the process for completing the square. Number 1, you want to move the constant term, c, to the right. Move c to the right. All right. Now, number 2, okay? I'm going to put this step in here, but this is really a moot point because we're doing just the basic ones. But I need to plug it in there just in case some of you want to go ahead and work on all your quadratic equations using this method, okay? We're going to divide both sides by the leading coefficient A. Now, here's the critical step right here, guys. That's the critical step. You're going to complete the square. To complete the square, here's how you do it. You're going to take half of B, square it, as in raise it to the second power, okay? And then whatever value you find, you're going to add it to both sides. Add it to both sides. Add to both sides. That's the critical step. Now, once you do this, step 4, factor the left side. And the left side is actually a perfect square trinomial. You want to factor it into a binomial squared. Okay, so factor the left side. It's a trinomial. You want to factor it into a binomial square. And then once you do that, the last step is to use the square root property to solve. So the square root property is what we just talked about. Now, if you don't fully understand this method, guys, it's okay. You can use the quadratic formula to do these problems as well. Remember, the quadratic formula will solve every single quadratic equation, people, okay? So you don't necessarily have to use these other methods. Now, here we go with the first example. Number 1. Oh, wait a minute. This is 7 from the assignment. It's x squared plus 12x plus 31 equals to 0. So my first step is to take that 31, I left out my x right there, and move it over. Now notice I'm leaving a little bit of space like right here, and we need some space over here too, okay? Now I'm leaving that little space there, guys, because eventually we're going to have to add something to both sides. And the a value for this problem is 1, so I don't have to divide both sides by anything. All right, so now I'm going to take half of the b value. The b value is 12. I'm writing it down here so you guys can see this. So I get 6. Then I take my 6 and I'm going to square it. So that gives me 36. So I'm going to add the 36. Okay, I'm trying to write a 3 here to both sides. Now, on the left side, I have a perfect square trinomial. On the right side, I'm just going to add up these two numbers together so I get 5. Now, for this, I'm going to factor it. I want 2 factors of 36 whose sum is 12. 2 numbers that multiply to give me 36 whose sum is 12. Some of you may see what's happening, but I'm writing it out so you could actually see everything. What you notice here, guys, is that the 2 binomials, this one and that one, they're identical. So we can take this and rewrite it as a binomial squared. So now you can just use the square root property to finish solving this. Take the square root of both sides. So you get x plus 6. Remember that plus or minus is equal to plus or minus the square root of 5. The last step is to isolate x. Remember, we're trying to solve for x here, people. So you want to get the x by itself. So what do? You take the positive 6, move it over to the right side. So the answer turns out to be a negative 6 plus or minus the square root of 5. And boom, there's your answer. All right, guys. I think I'm going to do maybe 2 more using the square root property. And then I'm going to move on. All right. Number 8, x squared plus 10x plus 11 equals to 0. Now, just like with the previous one, I am going to move the 11 over, leave a blank space for when you do complete the square. So now I'm going to take half of 10, which gives me 5. Then I'm going to take my 5 and square it. I get 25. So I'm adding 25 to both sides to complete the square. So now I'm going to factor the left side. Here's the shortcut. Okay, shortcut coming, guys. So to get quickly to my binomial square factor, I am going to take an x from the x squared and take half of the 10. So that gives me a positive 5. Let's look at that. That was easy, right? So now I can use the square root property and solve. Take the square root of both sides. So I get x plus 5 is equal to plus or minus the square root of 14. And then I am going to subtract the 5 from both sides, or just move it over, guys. Subtracting the 5 from both sides, moving it over is the same thing. It was positive on the left, it becomes a negative on the right. So there's your answer, people. There's your answer, okay? So that was our second example. I'm gonna do one more using completing the square, guys. Okay, one more. Or should I do, yeah, I think so. I'm just gonna do one more. Okay. All right, so now here comes number 9. Number 9, I've got y squared plus 8y plus 25 is equal to 0. This is, again, perfect candidate for completing the square. The leading coefficient is 1, as in the number in front of y squared is 1. And the number in front of y is even. 8 is even. So perfect candidate for completing the square. So I'm going to take that 25, guys, move it over. So it becomes a negative 25, okay? Now next, I am going to complete the square. So I'm going to take half of 8, which is 4. I take that 4 and I square it. So I'm going to get 16. So I'm adding 16 to both sides. Now, do that little trick, guys, to get to that binomial squared. You take a y from the y squared, half of 8, that gives you 4. There you go. That was quick. So now you take the square root of both sides. Be careful with this one. When we take the square root of both sides, remember, number 1, you get a plus or minus solution. Now, for this one, this is a special case. Because you have a negative under the root, that's going to become an imaginary unit. And furthermore, you can actually take the square root of 9 and get an exact value for it. So this is going to come out to be plus or minus 3i. But wait, there's more. We're not done. So you got to take that positive 4, guys, and move it over to the right side so you can solve for y. In other words, subtract the 4 from both sides, or just move it over. So it becomes a negative 4 plus or minus 3i. And there you are, people. There you are. Okay. So now I feel like I've done enough examples for you guys to be able to get everything. So let me go ahead and just give you a quick summary for the remaining problems. Number 11 can be solved by factoring. You can factor that one. I'm not going to do it. Next one, number 12. Ooh, let me say something about number 12. It is z squared plus 21 is equal to 10z. You got to set the quadratic equal to 0. Take the 10z, move it over. Make sure you write it in descending order of powers, guys. Descending order of powers. As in, you go from the highest power to the lowest power. So once you have your quadratic equal to 0, you can eyeball this and know that this is factorable too. Two numbers are multiplied to give you 21 and add to give you a negative 10. That would be negative 7, negative 3. So it works out. So you can finish solving it by factoring. Yay. Okay. Ooh. Number 13 is also factorable, guys. Factor it. All right. Now, let's see here, 14. 14 is a special case. The z squared plus 14z. They want to know what constant, as in what number should I plug in over here so that this binomial is a perfect square. That has to do with completing the square, guys. So you do half of 14, which is 7. And then you take the 7, you square it. So you get 49. So the number that's going to go there, let me use a different color so you can actually see it, is going to be 49. Okay. Now, the next part of this, let me go ahead and type in this answer so I can see the next part, what it's asking me to do. I think it's asking me to factor it. Yeah, factor the trinomial. But guys, this is a perfect square trinomial. So let's use the shortcut. You take a z from the z squared, half of 14, that gives you 7. So there's your binomial factor. And that's it. Okay, so now I'm getting into the word problems, guys. Here comes the first word problem, and it's number 15. We just got a few more problems to go. Neglecting air resistance. The distance in feet traveled by a free-falling object is given by the formula S of t is equal to 16t squared, where t is time in seconds. The height of a certain tower is 800 feet. By the way, S of t is the height. So guys, if they're telling you the tower is 800 feet, that means that they want you to go ahead and plug in 800 for S of t. So S of t is equal to 800. Okay, this is a t here. You guys know my iPad is cracked right there. That's why it's not coming back. How long would it take an object to fall to the ground from the top of the building? So your job here is to go ahead and solve for t. And then they want you to round the answer to 2 decimal places, 2 numbers after decimal. So you want to isolate the square term by dividing both sides, guys, by 16. So once you take that 800 and divide it by 16, that leaves you with 50, okay? Now, this is the square root property. You want to take the square root of both sides. You will get plus or minus the square root of 50. And let me go ahead and get a precise value for you. And the precise value, we're running it to 2 decimal places, is 7.07. However, guys, remember, we're talking about time. Time can only be positive. It cannot be a negative. So the answer for this one is just the 7.07. So it's going to take 7.07 seconds for the object to hit the ground, right? That's number 15. Now this next one is super easy. The area of a square room is 288 square feet, okay? So what you have to realize is to find the area of a square, guys, you have to know that formula. Since the sides are equivalent to each other, basically it's side times side, because the sides of a square are all equal. They're the same thing. So another way of expressing this is A equals to side squared. Now they're telling you the total area is 289 square feet. And then you got to find the dimensions of the room. So you got to fill in the blank. The side of the room is how many feet long? All you have to do with this one, guys, is take the square root. Come on now. You just take the square root, and that's going to give you 17. That's it. Now remember, it's supposed to be plus or minus, but we're not concerned with the negative because this is the side of a room. You can be having a negative length for a square, guys. That wouldn't make any sense. So this one is just 17. All right, next one, number 17. Ooh, how interesting. The answer is 17, and then we got number 17. Yes, okay. An isosceles triangle has legs of equal length. Okay, remember an isosceles triangle, guys, is a triangle with 2 equal sides, just like that. According to the figure here, both of the legs are x units long, and the hypotenuse is 4 units long. Find the length of each leg. Ooh, I hear the Pythagorean theorem coming. Okay, so the Pythagorean theorem, guys, a squared plus b squared equals to c squared. Or you could reverse that and say c squared is equal to a squared plus b squared. Of course, a and b represents the 2 legs. Now, the 2 legs of this triangle are x and x. Oh, let me go ahead and change that. Let me just erase this part right here, guys. Let's erase that, okay? C is 4, and then each leg is x units. So I'm just substituting in those values, filling in the information. So I get 16 is equal to 2x squared because I had 1x squared plus another one, so I have 2. And I'm going to divide both sides by 2, so I get x squared is equal to 8. Now this one right here says simplify your answer, type in unexact radical, which means no decimal, guys. So you got to take the square root of both sides, and you got to simplify that square root of 8. Now, square root of 8 is the same thing as 4 times 2. You take the square root of 4, and that's going to give you plus or minus 2 radical 2. But guys, once again, what are we looking at? We are looking at the leg of a triangle. Can it be a negative value? Absolutely not. So you need to reject that negative value. So the answer for this one is therefore just going to be 2 radical 2. Be careful, students. Be very careful, okay? Now, next question. We've got a fill in the blank. Ooh, I love this question. If you are depositing money in an account that pays 3%, would you prefer the interest to be simple or compound? You guys know what the answer for that is going to be. I've taught you better than that, okay? You would earn more interest with the first blank, compound interest. And then the second blank, because compound interest again, okay, earns interest on the principal and on interest already earned. Whereas the third blank, simple interest, guys, which we don't like, interest only earns interest on the principal. So simple interest only earns interest on the principal. Here comes the last problem, number 19. That was 18, by the way, so sweetie pies. Okay. A common equation used in business is a demand equation. It expresses the relationship between the unit price of some commodity and the quantity demanded. In the equation, P represents the unit price. Here, let me write the equation down. And X represents the quantity demanded in thousands. A company sells desk lamps and has found that the demand equation of a certain type style of desk is given by the equation P equals to negative X squared plus 14. Find the demand for the desk lamp if the price is $8. In other words, if P is equal to 8, what is the value of X? They want you to round this to the nearest whole number, okay? You can't have part of a lamp anyway, so it has to be the nearest whole number. So we're gonna fill in, we're going to substitute 8 in for P, okay, that's the price. We're gonna subtract 14 from both sides. Oh, I put 16, guys, did you see that? Okay, 14. So we get a negative 6 is equal to negative X squared. All right, so here we're gonna go ahead and divide both sides by -1 or multiply everything by -1. So we got 6 is equal to X squared. By the way, guys, X is the quantity demanded in thousands, because I know you guys are looking at this and saying, wait a minute, this is really small. You're right, you're absolutely right, okay? So now we're gonna go ahead and take the square root of 6. So that's gonna give us 2 point blah, 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 but we need to round this to the nearest whole number. So I'm just gonna go ahead and type this into my calculator, okay? And so we need to round this to the nearest whole number. And so when you type this into the calculator, guys, be very careful. So I get, okay, let me go ahead and do this. Okay, let me write this down for you guys. I get 2.4449, but this is supposed to be in thousands. So you actually need to multiply this by 1,000, multiply it by 1,000, okay? And so the answer, be very careful. The answer, don't put that just that decimal in. You got to put in the answer in thousands, because remember, this represents a whole bunch of lamps, okay? So the answer for this one is going to be 2449, as in 2,449 lamps. All right? Okay, guys, that is the end of assignment number 27. Hopefully you learned something in this process. I'll see you in the next video. Bye, sugar plums.